All right, so review of exponential and linear functions. We're going to be doing a lot of comparing the two, looking at it as an equation, looking at it in a table, looking at it graphically, and then looking at some written descriptions, trying to figure out which one is which. So as we look at linear equations, we've talked about two types. We've talked about standard form, which is ax plus by equals c. And we've talked about slope-intercept, which is y equals mx plus b. So that y equals mx plus b is really what we're going to focus on here today in this video. So y equals mx plus b, we have m in the problem. M is going to represent my slope. That's going to be my rise over my run. That's going to be my rate of change. That's going to be the value that is going to be repeating. And then we have our y-intercept, and our y-intercept is our b value, and that's going to be where it crosses the y-axis. That is going to be the initial value. And we still have some of those same key features when it comes to exponential functions. But exponential, my equation is y equals a times b raised to x. So in order to be an exponential function, it has to have a variable in the exponent. So the a in this problem represents my y-intercept, my initial value where it crosses the y-axis. My b represents my base, and the most important thing about the base is going to tell me one of two things. It's going to tell me if it's growth, because it's going to be greater than 1, or it's going to tell me that my exponential function is decay, because it's going to be between 0 and 1. So again, linear, we have y equals mx plus b. Exponential, we have y equals a times b raised to x. In order to be exponential, my variable has to be in the exponent. So just a few examples. If I'm looking at a, I've given you 3 equations. And of these 3 equations, I want you to tell me, is it linear or exponential? So a is going to be linear, and it's going to be linear because my x is being multiplied. So the x is not in the exponent. So therefore, it is still going to be a linear function. All right, b is going to be exponential. It's going to be exponential because my variable x is in the exponent. All right, so my a value is 1 times the 1/2, so my base is 1/2 raised to x for exponential. And my c value, or my letter c, is going to be linear. That's a times x, so my slope is 2. So y equals 2 times x, so my slope is 2, and my y-intercept, you don't see it, so it's automatically 0. All right, so in a table, so we talked about in a table, we have, for a linear function, we have a common difference, which means we're going to add by the same amount each time. Or for exponential, we have a common ratio, which means we're going to multiply by the same amount each time. So again, as I'm looking at my table, I see that I'm multiplying by 1. And the reason I still want to check my x values is to make sure they're changing by the same amount as well. So when I'm looking at from 3 to 5, we're adding 2. From 5 to 7, we're adding 2. And from 7 to 9, we're adding 2. All right, and then with exponential, we're going to multiply by the same amount each time. So again, I have over here on this side, and I'm going to make a correction, guys. I put times 1, and that is definitely not right. That should be plus 1 each time. So plus 1 each time as I go through those. So again, with my x values, I'm adding 1 each time. I just want to make sure I'm changing by the same amount, because if I'm not changing by the same x value each time, then that means I'm going to skip some y's, and that may change the pattern as well. So then I'm looking from 3 to 9, from 9 to 27, and then 27 to 81. I can definitely tell that I'm multiplying by 3 each time. So that common difference means I'm going to add each time for linear. For exponential, it means I'm going to multiply. All right, so I have 3 tables here, and looking at my first table, so we'll call this table A. I want to know, is this linear or exponential or potentially neither? Alright, so as I look at this table, I can see that I'm changing over here by the same amount, so plus 1, plus 1, plus 1. And then my y values from -1 to 1 is plus 2. From 1 to 3 is plus 2. And from 3 to 5 is plus 2. So this is going to be linear. Alright, so we'll go to table B. I'll label that. So again, we're changing by the same amount for my x each time. So that's fine. And then I look at my y's. And as I look at my y's, I should see that I am multiplying by 2 each time. So since I'm multiplying by 2 each time, this is going to be exponential. Okay. Same thing, we'll call this table C. Now, the only difference here is when I look at my y values, I see that they're going down. So everything we've kind of looked at so far has been increasing. So the relationship that I see here is I see that it's dividing by 2. Well, if I'm dividing by 2, that's still going to be a multiplication problem, but it means we're going to multiply by the reciprocal. So we're going to multiply by 1/2. So dividing by any number is the same thing as multiplying by its reciprocal. So if I was dividing by 3, I would be multiplying by 1/3. If I'm dividing by 5, I'd be multiplying by 1/5. Alright, so just an example that was in the released testing version for EOC in previous years. It says Monica did an experiment to compare 2 methods of warming an object. The results are shown in the table below. So I have method 1, the time, and method 2. So I'm just going to kind of highlight to kind of help it easier to see. So this is method 1 that we're going to wind up comparing. And then this is going to be method 2 that we're going to compare. Okay. So it says which statement is best describes her results. So it says A, the temperature using both methods changed at a constant rate. So a constant rate is something that you need to understand and remember that constant rate is the same thing as them saying linear. That means that we're changing by the same amount each time when it comes to adding that common difference. So basically they're saying for A that they're both linear. So if you see constant rate, they ain't linear. So when I look at it, if we're linear, then it's going to be adding by the same amount. So I have plus 5, plus 6, plus 4, plus 4, and then we have plus 6. So they're definitely not changing by the same amount each time as far as addition goes. For method 2, if we did addition here, we would say that this is going to add 1/5 or 1.5. This is adding 3. This is adding 6. This is adding 12. This is adding 24. So again, that is not going to represent a linear function because they're not the same. So we know A is not correct. So the temperature using both methods change exponentially. So to change exponentially, that means they're going to multiply. Well, there's nothing that when I'm at 0, I would have to multiply by what to get 5? Okay, well 0 times anything is still going to be 0. So there's nothing that I can multiply here if it starts at 0. So I can definitely tell you that there's no multiplication here. So there's no multiplication in this problem. So then I look at method 2. So method 2, I have 1.5. I would have to multiply that by 2 in order to get to 3. So we're going to come over here since we already did the addition. I'm going to mark that out because we know it doesn't work. So we're going to do times 3. So, excuse me, not times 3, times 2. And then 3 times 2 again will give me 6. 6 times 2 again will give me 12. Times 2 will give me 24. And again. So we know that they are both not exponential. But at this point, I now know that at least method 2 is exponential. So C says the temperature using method 2 is constant. We already determined that wasn't true because constant means linear. And we already determined that wasn't linear. So method 2 changed exponentially, which is the answer to D. So again, in a table, linear is going to change by addition. The exponential is going to change by multiplication. All right, so then we're going to look at graphs. So linear, they should look like a line, hence the reason they're called linear. But when we look at linear functions, we read graphs the same way we read a book. We read it from left to right. So if I go from left to right here, so if I start on the left-hand side and I go to the right, that means that we are actually going to be increasing here. And that increasing means that I have a positive slope. All right, and for the second one, I'm going to start from the left, and I'm going to go to the right, which means I'm going to be decreasing, which means I'm going to have a negative slope. All right, and exponential, we still read it from left to right, but the great thing is we actually have letters that we've talked about before that represent this. So exponential left to right has that J shape. J shape is going to represent growth because it's going up. And then if I read this one from left to right, it's going down. It has an L shape, and an L shape is going to represent decay. Okay. So then we have some written descriptions. So written descriptions are, can I read a situation and determine whether it's going to be exponential or linear, or maybe it's not either. So I was just going to read through these and just kind of talk through them. And we're going to kind of label them exponential or linear. So it says, a taxi charges an initial fee of $2. So that initial fee is going to be my y-intercept. So that is my first thing that I'm going to recognize. That's a y-intercept. And $1.50 for each additional mile. So if it's an additional mile, that means that it's going to repeat. That means it's going to add for every additional mile. So therefore, this is going to be a linear function. Because remember, we talked about the fact that slope has a repeating value. That repeating value is what's being added each time. And then we have that y-intercept, which is the initial amount. Anytime they talk about per or each, most of the time that's going to represent linear. All right, so for the second one. So the second one, it says a population of town decreases by 15%. The fact that they told me 15% here should be an indication for me automatically that this is going to be exponential. All right, so then our next one, it says that an airplane is flying at an altitude of 33,000 feet, so that's going to be my initial. It's descending, so it's going down at 20 feet per minute. So 20 feet per minute, that per should tell me that it's representing slope. So slope is going to represent linear. All right. And my next one. So it says a pizza restaurant charges $5.50 per pizza. So $5.50 per pizza is going to, I know that per is kind of confusing for people initially, but we're paying $5.50 up front for my pizza. So that's going to be my initial amount. And then we're going to pay 50 cents for each additional topping. So that's going to be that repeating amount that we're going to add on. For every topping, we're going to add on add on 50 cents. So that is going to represent linear as well. All right, and the last one says that a cell doubles in size every 2 hours. So doubles means to multiply by 2. Multiplication is exponential. So hopefully that can help you recognize exponential and linear a little bit better. So remember, percentages, doubling, tripling, halving, those all mean exponential. Linear, you're going to have an initial amount, and then it's going to give you some form of repeating value that's going to be added or subtracted each time. All right, so this was another example pulled, and it basically says which choice can be modeled by a linear function. So A says the amount of money Y in the account after 4% interest compounded annually. B, the monthly cost Y to a cell phone for service at a rate of 4 cents per minute. C, the height Y of a ball after bouncing X times if each bounce reaches 2/3 of its previous height. D, the amount Y of radioactive material remaining after X years when decay occurs at a rate of 30%. So, given these answer choices, I would have to say that if we're talking about looking for linear, the only one that represents linear is going to be B. Even though it says a rate, don't think of a rate as a percentage, as saying that it's changing a rate of change, a constant rate by 4 cents per minute. So that 4 cents is being added each time to the bill. A had a actual percentage, that was exponential. C, it said that the bounce reduces by 2/3 each time, so that means that we're multiplying it by 2/3 each time. So again, that's going to be exponential because we're multiplying. And then D, the amount of radioactive material remaining after X years when the decay occurs after 30%. So we have a percentage again. I hope this helps you review some of the things that we've discussed as far as comparing exponential and linear functions.